Hey guys, Mr. Gran, 8.4. In this video we'll be graphing rational functions. So what are our steps for graphing rational functions? They are these. We're going to start by factoring the numerator and denominator, using the factored form, our degrees, to figure out all of this important information, these important elements, zeros, holes, the y-intercept, and vertical and horizontal asymptotes. Then we're going to graph all of those things accurately, and then we're going to check our graphing calculator to see what the general shape of the graph is, and then we're basically sort of just connecting the dots that are on the graph. All right, so first example, we're going to start out by factoring this. The top is factorable. It factors to -4 and +1. The denominator is not factorable. It's just x. And nothing cancels out here, so I'm pretty much good to go. Zeros. Whatever makes the top equal to 0 makes a 0 on the graph. So that is going to be 4, 0, right? Our x-coordinate's 4, our y-coordinate's 0. And then for the x plus 1, it's -1. So the +4 came from this one, the -1 came from this one. Holes in the graph, nothing canceled out, so there's no holes. Vertical asymptote, what makes the bottom equal to 0? 0, right? If I plug in a 0 for that x, it's equal to 0, so it's 0. Horizontal asymptote, looking at the degree of the top is 2, the degree of the bottom is 1, bigger degree on top, that means that we have no horizontal asymptote. And then our y-intercept, remember for the y-intercept, you can find the y-intercept when you plug in 0 for x, right? So if I plug in 0 for x, I get 0 squared minus 3 times 0 minus 4 all over 0. And what happens there? The top, 0 minus 4, over the bottom is 0. When you divide by 0, it's undefined. And so that means there's no y-intercept. So our y-intercept is none. Which makes sense because we have a vertical asymptote as the y-axis, so it doesn't cross that. Okay, so it never crosses the y-axis. Our zeros, so let's plot all this stuff. Zeros are at 4 and -1. We have a vertical asymptote at x equals 0, excuse me. Like that. And now I want to check my graphing calculator to see how this looks, how I connect through those dots, and how it interacts with the vertical asymptote. Okay, so one thing I want to point out, make sure that you put your numerators and denominators in parentheses. If your graphing calculator can plug it in just how it looks, where it's everything on top and bottom of a big fraction bar, then you can do it just the way it looks. Otherwise, the numerator needs to have parentheses around it. This one didn't because it's x for the denominator, so I don't need to put parentheses around the x. But all the rest of them, I've got parentheses around the numerators and denominators. Okay, so looking at the graph, I can see that it crosses my zeros at -1 and +4. I can see my vertical asymptote here and kind of how it interacts with that. And I can use that to sketch the shape of the graph. So if I go back, on this side it came in from below and it crossed through through that 0 and then followed the asymptote up. On this side, it's coming from the asymptote, curving out, and then kind of going off at an angle like that. All right, next example. So again, we want to start by factoring this. Now we've got some GCF and some difference of squares factoring. So on the top, both terms have x. That means I can factor out an x. And what I'm left with is 3x plus 1. On the bottom, it's a difference of squares, so that's going to be x plus 3 and x minus 3. Nothing cancels out, so let's take a look at all these things. What makes the top equal to 0? If x is a factor, then 0 is one of the zeros. And then this one, the 3x plus 1, that one, maybe I know a good trick for it. Maybe I just have to set it equal to 0. And solve it. Either way doesn't matter, right? So we get x equals negative 1/3, so negative 1/3, 0 is the next 0. Holes in the graph, there's none because no factors canceled out. Vertical asymptotes, there's 2 of them now. What makes the denominator equal to 0? That's going to be a vertical line at x equals negative 3 and at x equals positive 3. So 2 vertical asymptotes. Horizontal asymptote, the degree of the top is 2, the degree of the bottom is also 2. So I'm looking back at the non-factored form for this. When it's the same degree top and bottom, the rule is that it's leading coefficient over leading coefficient. So this is going to be y equals 3 over 1, or just y equals 3. And then the y-intercept, I want to plug in 0 for x for the y-intercept, so that's going to be 3 times 0 squared plus 0 over 0 squared minus 9. That ends up being 0 over negative 9, which is just 0. So the y-intercept is 0, 0, the coordinate 0, 0. 0 for the x-axis coordinate, and then also 0 for the y-coordinate. All right, let's start plugging all this stuff in. I've got zeros at 0 and at negative 1/3, so they're real close to one another. Kind of a tough one to show on here, but you know, do your best. No holes, vertical asymptotes at negative 3 and positive 3. A horizontal asymptote at positive 3. And the y-intercept is at 0, 0, which I already have there. It's the same as one of my x-intercepts. Okay, looking at the graph, go to my graph calculator. So now it's the second one. Notice I've got parentheses around the numerator, parentheses around the denominator, so we're good there. And if we graph it, it looks like that. So we can see the vertical asymptotes, and we can kind of figure out where the horizontal asymptote in there. So it's sort of like it's divided into thirds. This third is in the top and shaped like that. This third, the middle third, kind of is a U shape between the asymptotes, and then this one on the right side kind of drifts off and levels out as it goes to the right. Okay. So plotting that, over here I don't have any numbers to any actual points to use, but I can just use the asymptotes to sort of sketch the curve. And then here it was following the asymptote up, it crossed through the 2 points and then followed the asymptote down. And then in this side, it's similar to over here. We're just sort of making a curved line within the corner of those 2 asymptotes like that.